Hi, myself Vasan. Welcome to our channel Evidhai. As part of the GCP upskill part, the Google Cloud Certificate Challenge, today we will go through setting up the network and HTTP load balancers which are offered by the Google Cloud. As a prerequisite, I already signed in. So the left side, we would be seeing the step-by-step instruction to perform, and right side, we have logged into the Google Cloud. And also I have went here ahead and launched the Cloud Shell, and I also set the default region to US Central 1 and the default zone to US Central 1C. So what is region, what is zones, we have already discussed in the previous session, and we'll proceed further on in terms of uh, understanding the load balancer and step-by-step instruction to get followed. So to kickstarted, we wanted to launch the virtual machine, which would be the instances or the server where our load balancers would get routed to. So rather going via console, so here we are trying to achieve it using the Google Cloud CLI, which is G Cloud, and the command we use is G Cloud compute instance, create the instance name, followed by which zone, any tags to be added, what type of instance we need, and what OS we needed, and under which specific uh, project, and this would be the booting script. So when we are bring the instance up, what should be the uh, commands that should execute so that we can have the web server up and running. All those things been given. So we just need to copy paste it to get the instance launched. And we can verify whether the instance is launched or not by navigating to the compute engine VM instance. This is where we should be able to see a instance named W1 once it's created. Also, the next thing is to do is to create the second instance with the name W2, and I believe the same set of things, just the instance name would get varied. So let's try to see whether is that got created or not. The command says it got created. Yeah, so the W1 is got created now. Let's try to run the command for W2, and the second instance will get created. Okay, so we're also going to create the third instance. Again, the same command, whichever we are using launch, and just the name of the server is going to get varied to W3. So let's wait for it to command to execute. And since these are web servers, we want to open a specific port. I believe we'll be opening the port 80 for the outside traffic to access. And we can achieve that using by creating a firewall rule, and that's what exactly we're doing here. So we are using the firewall command, which is gcloud compute firewall rules, followed by the rule name and what is the target tag. So what instance which is mapped. So we are tagging with the tag network lb tag, and you would be seeing that while creating the instance, we tag those instance with the specific value. So tags is equal to network lb tag. So any instance that consists of the specific tag value, which is network lb tag, we are going to allow for the port 80. That's the firewall rule we're asking the GCP to create. So once this is done, we can run the command to fetch the external IP. So first we are getting the list of instance, and from there we are going to get the external IP out of it. So if I do it, it's going to give all the details about like the instance name, which region, machine type, and external IP. We would need just the external IP details so that we can see whether the port is opened or not. And here they're asking us to check it with curl. We can also do the curl, or we can also directly hit the URL browser and see whether are we getting the web server response from the server or not, right? And also you can see that it is a response at W2, which means this belongs to the, or like we are hitting the web server 2, which we launched. Um, if you hit the web server 3 external IP, then you would be getting the response as WW3. And from where this information is being launched is from the uh, initial boot up script which we given. So this is where we declare like for this specific server in the index file, write it as web server W2, and for the web server W3, we are writing it as W3, and those information is getting displayed here when we were directly calling the home page, which is the defaultly served. So going further, we can check our progress. So we have created 3 instances with Apache server installed and it's working. So next is we are going to configure the load balancing service. And here they offer like 2 different types of load balancer. One is the network load balancer and the HTTP load balancer they call it as, which will be generally the application load balancer. So here we see about the network load balancing from the external TCP or UP. So create a static external IP for a load balancer, and okay, let's create it, and then we'll discuss about like what they talk about. Uh, so to create the external IP, we are creating compute address create followed by the public IP we are creating, right, and which region we wanted it. So let's execute the command here. So one thing I'm liking here is like uh, we are trying to avoid as much manual change and we're going with the CLI commands. Add a legacy health check resource. Okay, so let's see what it does. And add a target pool in the same region as your instance. Run the following, create the target pool and use health, which is required for serve function. So the target pool is going to be this, and then we are mapping the health check to the specific target pool. So you want to see what is target pool and what is the health check going further. Add the instance of the pool. So we created a target pool, and then now we are adding the instance, and we are adding the instance based on the name we provided. So if you recall, we provided name as WW1, WW2, WW3, and we are mapping those instance based on the name to the target pool which we created just a few seconds back. So for now we created an external IP and then we created a target pool and then we are mapping the specific target pool to the uh, we're mapping the instances to the target pool which we created. So once that is done, we are adding the forward rule to the load balancer, which would be you can see compute forwarding rule create, and we are mapping to the specific address, which will be the external IP we created, which would be this, and target pool of this one. So I believe for the network load balancer, which we talk about, it's just about adding the network address. In our case, we created a public external IP address, and that's how they're going to. We're directly creating the forward rule over there. That's how it works, I believe, in the GCP world. So if I check the progress, we could see that this is completed. And sending traffic to instances. Now that the load balancer is configured, you can start sending traffic to forwarding rule. So how can we do that of sending the traffic? So we can see that and to view the external IP address of the, okay, so we're using a describe command here. So in the previous command, we used create, which created a forwarding rule. And now we are going to describe the forwarding rule to see like what are the uh, things that exist. So this is going to give us what are all the values that exist as part of the load balancer, and we could see it's a region, forwarding rules, SSL link, and more details been given. Assess the external IP address. To get the external IP address, we are fetching just the .ip address. So we can see the IP address here. And since we get this as the part of JSON response, they're using jQuery, which is JQ, and then we're iterating to the output and then just getting the external IP address, which is .ip address. So it's again pure how you write the shell scripting part in the bash. So we are storing the value in a variable called IP address. The value which we get is by executing a CLI command, and here we use the pipeline. So which means whatever the output we get from here, this command, we pass it as the input for the next command. So for example, uh, if I say, let's say echo and then hi, and then if I pipeline it to the next command, which would be like, let's say wcl, it says like how many lines it exist or the number of word count it exists. So we can play with it. So this can come handy. For example, I can do like, instead of using, you see, describe this one, and then I can say grep, which is like filter the lines, and then I can ask like give me the line only which consists of IP protocol in it. So this would be given like the specific value like IP protocol TCP. But since we don't need the specific entire line, but we just need the value of a specific key. In our case, we need the value of a specific key, which is IP address. What we are doing is we're using jQuery to read the JSON output of a specific key. In our case, it is going to be the IP address. So to do that, we can do is instead of using grep key, we use JQ followed by hyphen R, and then what we need. So if I do just dot, it's going to list all the specific, okay, it's giving an error. So if I just do JQ hyphen R, let's see. Okay, let's give JQ and wait. Okay, so we need to run this specific command gcloud.json, right? Sorry, my bad. I was running something different. So if you run this specific one, so this is give us the specific value, and if I iterate this one into jq-r, for example, dot, again it would give all the specific values, which is just here. And now if I need the value of, let's say, self link, I would give dot self link, or if I just need IP address, I can give dot IP address, and then we can get the specific value of the specific key, which will be like IP address is a key, and this is the value. So we get the CLI output as a JSON by passing the specific parameter format equal to JSON. So it's a key factor, like how we can play with CLI, and we are storing the output into a variable called IP address. Okay, so the external IP address, we can read the environmental variable using dollar, the environmental variable name, and echo is a command to print out the value, and which we have seen in the previous sessions, I believe. So yes, the environmental variable is working. Now you can see curl hyphen, it says em1 IP address. You can also directly try hitting the specific IP address and see what happens. So it should ideally give you the, it's going for WW1 now. And if I keep hitting, or let's try doing this one. So what we're doing here, while true do curl, the response from the curl command alternates randomly among the three instances. Initially unsuccessful, wait approximately. Okay, yeah. So for us, it started coming because once the rule is created, I believe it's going to take like 30 seconds. That's why they say like wait for initial 30 seconds. And let's try continuously execute the command. So here we say while true do curl and then the specific one, and it's just going to keep on hitting. And we could see that here that we get random response. Like sometimes we get W1, sometimes we get W2, and what does it mean is each time we get navigate to a random server. So we have installed three instances, W1, W3, and we also seen that based on the server we get the specific output. So if you're hitting the instance W1, you're going to get W1 as the output. So that's what is happening here. The load balancer is doing the job to take us to a specific or like random one. So far what I have seen is the network load balancer. The next task we are going to do is create the HTTP load balancer. In generic, the major difference between the network load balancer and the HTTP load balancer is since the HTTP load balancer sits in the application layer, we would be ideally able to route it based on the path, which means I can say if the path is /image, route it to the bucket storage so that all the static files can be hosted over there and fetch it from that, rather point it to the specific server, or you can have one server for a specific application and then you can route it like all the API calls like /API endpoint /API, then route it to the API specific server. We can play with it. So that's what we are going to do. So in the previous, you have seen about the network load balancer where we created the external IP address and we created a target pool, and then we mapped all our web instances to the specific pool, and that's how we got the routing rule work. And also we created the forward rules to map our pool to the IP address part, right? External IP address of the load balancer we created. Same way, let's try see like how we are going to do with the uh, HTTP load balancer. I wonder like why they call it HTTP load balancer, not HTTPS load balancer. Might be that it supports both. Yeah, so S is optional, which means it supports both HTTP and HTTPS. So HTTPS is something where we route it with the port 443, which would consist of a public certificate from a certificate authority, which is more secure. And that's what used in a production level domains. Like as you see, uh, every domain would consist with HTTPS, right? Um, so let's create it now. We have like the first command to use to create the load balancer template. Okay, so we create a template. Instance templates. We have the regions, health check, machine type, image family. Okay, and then we are also having the startup part, which is the same script which we used. And here to denote, we say like from where the file has been getting served. Okay, so first we are going to create the load balancer template. So this is something I'm trying it for the first time. We'll see like what happens. So first we are creating the load balancer template, and this can help us to manage multiple identity VMs. So once done, we are create a managed instance group based on the template. Okay, so you can create the managed template, which is like we are creating a size of 2. Let's do that. And create uh, firewall along health check. Okay, so we are creating a health check, and this is for tagging and this is for ranges. The ingress rule allows the traffic from Google Cloud health checking systems, which is 130 dot. The lab that uses the target group to identify the VMs. Okay, so we are creating a firewall rules to map specific IP address from where the health check will be tested, and we are mapping this specific firewall rules to the instance that are tagged as allow health check. And if you see, I believe you would be already tagged the instances to allow health check. You see in the template, we already done that. So any VMs that created out of the template would already have this specific tag allow health check, and we are creating the firewall to allow the specific port 80 from the specific range of IP address, which are tagged as allow health check in the instances. That's what the firewall rule which are creating does. So once the instances are created, uh, we are creating the IP address, external IP address v4. So once it's created, we are again reading the created IP address, and we are creating the health check for load balancer. Okay, I'm not sure like why we create the external IP address here. Since I'm looking it for the first time, let's see like how it goes. So we created the IP address for this, and then this is going to list the IP address because we are using the because here we are describing the IP address, and then here we are creating it for the health check. Give me a minute. So this is the health check we created. If I go with describing the load balancer, we got the public IP address which we reserved it. Okay. So the Google Cloud provides health checking mechanism that determines whether backend instances respond properly to traffic. So next is we are creating a backend service, and what does it does? Okay, in the network load balancer, we created the target pool, and here for the HTTP one, we are creating the backend service, I believe. And let's do that. Let's see like how the uh, final things works, and we'll try to recap like what we are seeing at the end of the video. So once this is done, okay, same like how we added our instance to the target pool. In the HTTP one, we are adding our instance to the specific one called the backend service. That's what we are doing here. So we are adding the backend to the adding our instances to the specific thing called backend service. And same way like how we created the forward rule, here we are using the URL map. Here we say uh, for HTTP. Okay, so this is the URL map name, and I think this one is just going to create the URL map, but no rule added to the specific map. Let's see. Yes, this target proxy will be mapped to the URL map resource. So by default, the URL map itself is not going to do anything, but the URL map is going to consist of the specific default service, which is like a default route where it should get go to, and then any specific rules like say the path / init should go to some XYZ server, then uh, we need to add it on top of it. So if we go here, let's see, it's going to create it out, and yes. So now we can add the proxy to the routes, which we say, uh, okay, even proxy is different, and then the forwarding rules is mapped to specific proxy. Okay, so we have the URL map, which consists of the default one, and then the proxy is being mapped to here. So you can see that um, compute target HTTP proxy. We are creating it with the name HTTP proxy, and then this proxy is being mapped to the specific URL map which we created. Now the URL map is created, then we are creating a forwarding rule which says gcloud compute forwarding rules, create the forwarding rule, and then here we say what is the IP address and what is it global, and what is the target proxy and what port we are routing it to. Okay, once this is done, as per this lab, we are done with the setup. And let's see. Don't worry, it's bit sounds like a lot of component involved, but we'll see what they're trying to achieve, or like what we're trying to achieve between the network load balancer and HTTP load balancer. What I can also do is I'll run the history command so that we copy all the commands we run so far, and so that we know what commands we used it as part of the lab, and I will share it as a description of the video so that uh, you people can use this if you're planning to perform specific replicate the lab scenario from your end in your own environment. Okay, so let's try to go through the documentation between GCP network load balancer versus HTTP load balancer. Let's go with network load balancer. So we have this one, how to between network and HTTP load balancers. And if you see the specific one, we have how to thread HTTP load balancer. We can map multiple regions to the specific load balancer, which is global load balancer. And that's what we did in terms of one of the command. We used -- global to denote the nature of the load balancer. And this is for external TCP or UDP load balancer. And you see it's specific to single forwarding rule from internet, and the specific region is over there. And we also have internal HTTPS load balancing. So in our specific lab, in both network and HTTP load balancer, we tried using external load balancing. We can also achieve the internal load balancing, and how to set it up and all those components is being provided here. So main thing we would do is about how this works. So user load balancer is that load balancing, and that takes you to the origin. Either you can take it to the storage bucket, or you can take it to the cloud engine backend, which would be the instances. So yeah, so I would say go and refer the documentation part of it. They have a rich documentation over here. So my key observation is that in the network load balancer, we are using target pool, whereas in the HTTP load balancer, we are using something called backend services, and that's where both the instances get mapped. And we directly create the forward rules when it comes to network load balancing, whereas in the HTTP one, we want to create the proxy and map it to the URL map, and then the forward rules added to the specific proxy part. So those are the major observation I observed at first glance of trying the uh, difference between the network and HTTP load balancer. But as a fundamental concepts, like as any other load balancer, you would generally go with HTTP if it's for application specific logic, like you want to control based on a URL path. Likewise, you would go with HTTP load balancer. If it's TCP UDP routing, you would go with network load balancing. That's the core concept, irrespective of what cloud provider you use. Okay, so it's more of a good learning for me in terms of like the CLI commands and taking it forward. And in both the cases, suppose a health check. So I need to still go and look for like what are they about. Right. The next topic is going to be on implement load balancing on Compute Engine. So if you haven't subscribed our channel, do subscribe and see you in the next video. Thanks.